Good afternoon, and thanks very much for the invitation to speak. We have, I think, an exciting story to tell you and an exciting picture to paint for you this afternoon of the future of clean energy management and clean energy abundance. And I'm going to start off by sharing with you the exciting vision of our university's net zero community project and why we feel this is a transformative and vital step to get to that future of clean, abundant energy. My colleague, Dr. John Preston, will follow with what are small modular reactors and what's the potential that they bring now to the energy picture, and Dr. Jim Cotton will talk to us about the future of energy management, a new paradigm in managing energy for abundance. And then we'll have lots of time for questions at the end. So we'll hold questions until all three of us have spoken. So you are at Canada's Nuclear University. For 65 years, we've operated on this campus the McMaster nuclear reactor with tremendous benefits in education, in research, in health, and in economic impact. And it is that expertise that we are looking now to leverage for the future to open up the pathway to small reactors being in communities and being at the heart of those communities and driving them to a future of energy abundance. It is enormous capability that it has driven having that reactor here on campus, and it's the only one in Canada and one of the few in the world that is in the size range of microreactors, the kind of small modular reactors that can be deployed around the world. So Dr. Preston's going to talk a lot more about SMRs, small modular reactors. Very, very briefly, they're small. They're much smaller than the reactors that we're used to picturing on gigantic nuclear sites. So they're deployable. I'll come back to deployable. They're modular. They can be manufactured in factories. You can have a supply chain coming. It gets us over some of the massive infrastructure problems. And they are an affordable pathway and a decarbonization pathway that can be deployed both in urban areas and in off-grid areas. So an important evolution, really, of nuclear technology that opens new possibilities. And I said they're deployable, and they are deployable, but we've got to start deploying them. And there's a pathway to doing that. Right now, Ontario, Canada and Ontario especially, are world leaders in the SMR pathway. And there's a grid-scale project underway at Darlington. There's a project at Chalk River I'm going to tell you about. These are first-of-a-kind reactor constructions, vitally important to prove the technology, and they're happening at places for micro reactors, for the very small reactors. They're happening at places like Chalk River and Idaho National Lab. These are massive, remote sites with huge infrastructure and emergency plans and security plans. This is where you want to build the first reactor and prove it. It is not where you can demonstrate how these reactors can drive communities. So if we're really going to get past the, to the part of benefit from these microreactors in our communities, we've got to get to the paradigm that exists across the campus. And I know many people are going to tour the McMaster nuclear reactor or have already in some cases. I hope that that's a wonderful experience for you. You're going to see a 5 megawatt, that's a significant energy source reactor in the middle of our campus. You can walk up, you can put your finger on the wall of the reactor from the outside. It is integrated into our community. That's what we've got to get to for microreactors. Building on giant nuclear sites doesn't get you there. There's a pathway. So why McMaster and why now? I think this entire this entire conference is focused on why now. There's an urgent need for new ways of thinking and new approaches to solve the problem of how we're generating and using energy. And that's We're talking today about the nuclear potential for that. This can also, not only for remote and off-grid communities, it can decarbonize urban heating and industry. Important sources of carbon, as Jim will talk about. And why McMaster? I'm not sure if I already mentioned, we have 65 years of experience operating a reactor in the size range of a microreactor. It's the only one in the country in that range. We can do this. We can make that transformative step forward in bringing this new type of small modular reactor, a microreactor, into communities and show how it can work. And at the same time, make a massive impact on decarbonization of our own campus. So our vision is to build a net zero community on the campus, a livable community of the future, micro-community of the future, with an SMR at its heart, driving an integrated community energy harvesting system, the approach that Jim is going to talk about in a couple of minutes, that will demonstrate the next generation of energy generation and energy management, and at the same time help us achieve our net zero goals. The vision is of a living laboratory, a visitor center where communities can come and see this technology at work, and where we can train the future people that are needed to operate, maintain, design, regulate, utilize these reactors around the world. At the same time, we'll be doing multidisciplinary research and leading the way through the life cycle of that reactor, so that communities that come after can come and see, we're going first, right? An institution with nuclear expertise and resources is walking the pathway first. So this is the vision of the net zero community. You see the expanded view in nuclear. We don't like to call it a blow up. You see the expanded view of the energy center, and I just want to clarify, that's the expanded view from that small yellow circle in the bottom. So to give you a sense of the scale of what we need here. And our vision is to, as I said, build a micro community, a livable micro community of the future with a micro reactor at its heart that will be a demonstration of what you can do with energy abundance. It'll be a demonstration and a training center. It'll be a place communities can visit. It'll be a place where we can try out the technologies that can benefit from the energy capture. So not only decarbonizing our electricity, decarbonizing our building heating, and then demonstrating, and we've focused a lot on deployments to Canada's Indigenous communities and northern remote communities, as well as off-grid industry. So thinking about things that are important to their communities but are energy intensive: water, desalination, purification, greenhouses that give year-round food security in our challenging climate, and importantly, carbon-free fuel production to create local energy economies. So making hydrogen or ammonia fuels that can drive a local economy. So an important, that's what I just said, and I'm not sure if I mentioned we have 65 years of operating the reactor. I can't stress enough, I think it's an important capability that we have a responsibility to deploy for the good of Canada and the world now. What will we be doing? If you look at the IAEA, International Atomic Energy Agency, guidance for countries that want to embark on nuclear, they have a milestone program. They have 19 areas of focus that countries need to develop. And Canada's not an embarking nation, but we are embarking on a new paradigm. And with microreactor deployments, different geography, different operators. And so we are now in Canada heavily nuclear reliant, especially in Ontario, but those are big reactors. They're only operated at 4 sites and by 3 companies. So, excuse me, and they're all very close to urban areas. In the future, we need to get a lot more nimble, have a lot more operators, and put these reactors where the energy is needed. And some of the things that will cross as important first-time experiences in this project is the approach to community engagement in that, the approach to how you put exclusion zones and handle the safety and security aspects of the reactor, how you operate them with not thousands of people, but tens of people, and how we get training and pipeline production going for the first operators. So today, with our partners at Atomic Energy of Canada, Chalk River Nuclear Laboratories, Natural Resources Canada, and the Saskatchewan Research Council's nuclear arm, we're leading an initiative, a pan-Canadian initiative, to bring microreactors really from the drawing board to the communities. There's a role for operators, there's a role for government, and there's a role for national labs to get us from the concept that they are really today to deployable, to where you can pick up the phone and order a reactor. Okay, it's not quite that easy. Uber doesn't deliver them. But we've got to make a pathway, a supported program to make that pathway open, and we're working on it. Where are we today and what are our next steps? So we've started with a vision development that you've seen. Check mark. It's a big part of the project. Then we looked at the question, can we do it? And we looked at the technical feasibility of putting one of these reactors on our campus and building a community around it. And can we do it? The answer is yes. The next question is, should we do it? And that's a governance question. And just before Christmas, our Board of Governors said, yes. I mean, yes, we should start on this pathway. There's many, many times they'll have to say yes again. But they said, yes, embark on project development. And now we're in the process of technology selection, and I'm going to wrap up, and building out our program. Okay, so why McMaster? Why now? Again, this is a project that will have generational impact and really open up this new era of energy abundance and energy management. I'll turn over to my colleague, John.